Hello, this is Laur Hesse-Fisher, and you're listening to Today I Learned Climate from the Massachusetts Institute of Technology. Here's something that people ask us a lot. Are we worried about the materials that go into solar panels and batteries? Sure, they help us head off the dangers of climate change, but what if making them pollutes our air or our water? And yeah, we are worried about this. Like, to name one important example, many batteries contain nickel and cobalt, and both of them are toxic metals that can harm miners and the people who live near the mines. But this got our team thinking. Why do we only hear these questions about new energy technologies?
We shouldn't forget that our current energy system, which depends primarily on fossil fuels, causes serious health effects because of the emissions of air pollutants that are involved in the combustion of those fuels.
That's Dr. Mary Rice.
I'm the director of the Center for Climate Health and the Global Environment at the Harvard Chan School of Public Health. And I'm also a practicing pulmonologist at Beth Israel Deaconess Medical Center in Boston.
When they're not treating patients, Dr. Rice and her colleagues study what climate change is doing to our health. And they also study what the coal, oil, and gas that cause climate change do to us. But how big of a health problem are fossil fuels really? After all, we've been burning them for hundreds of years. Wouldn't we notice by now if they were harming us?
I think we often don't appreciate the harms because we're all exposed. And so there's a tremendous amount of death and illness around the world due to air pollution exposure that I think is really underappreciated. So I'd like to tell you a story about air pollution and how the scientific community realized how deadly it really was. In early December 1952, a cold fog descended upon London. And because of the cold, Londoners began to burn more coal than usual. And at the same time, the final conversion of London's electronic trams to diesel buses was completed. And the resulting air pollution was trapped by a heavy layer of cold air. The smog was so thick that people actually couldn't even see. And in the weeks that followed, the medical services compiled statistics and found that that fog had killed 4,000 people. And another 8,000 people died in the weeks and months that followed.
This became known as the Great Smog. And it was one of the first times that medical researchers looked at two crucial pieces of data together: how much smoke was in the air from burning coal and diesel, and at the same time, how many people were dying of heart and lung disease. And it turned out that when the first line went up, the other shot up right alongside it.
And that event in some ways was the beginning of environmental epidemiology, where the researchers could look at the data and make a clear link between pollution exposure and death.
We've now had over 70 years of public health research since the Great Smog. And time again, we found the same link. When people are exposed to more air pollution from fossil fuels, we get sicker. But what exactly is it that makes us sick? Well, burning coal, oil, and gas can put lots of things into the air that are unhealthy to breathe. Nitrogen oxides, ozone, carbon monoxide. But the most dangerous is what scientists call fine particulate matter.
And that means little particles of carbon and metals that are suspended into the air and can be inhaled. And they're small enough to be breathed in all the way down into the alveolar sacs, the part of the lung where gas exchange takes place. And in that area of the lung, the particles cause inflammation, irritation.
Think about when you get a splinter. Your skin gets inflamed, right? Red, swollen. Now imagine that happening inside your lungs, day after day, just from breathing in dirty air.
And that inflammation has a spillover effect into the rest of the body, leading to health effects in distant places. And that explains why particulate matter pollution has been linked to heart disease, brain disease, cancer, developmental delays in children, cognitive health effects, changes in pregnancy outcomes.
Which are all illnesses that we see more often in people who spend a lot of time around fossil fuel pollution.
Certain occupational groups are more heavily exposed, right? So if you work in the transportation sector, you're exposed to air pollution at your daily job. If you're in manufacturing, exposure can be quite high. Traffic pollution has also been declared a carcinogen by the WHO, and that's in part due to evidence from people in the trucking industry who were heavily exposed to traffic and had a higher risk of lung cancer.
Air pollution from traffic can even affect how kids think and learn.
A study in Massachusetts by my colleagues found that kids who lived within 50 meters from a major roadway had lower nonverbal IQs, and they actually had a worse ability to do tasks that require hand-eye coordination compared to kids who live further away from roads.
Then there are what we might call environmental pollutants. So these are ones that can linger in the environment for a long time, sometimes with some particularly nasty impacts.
When coal is burned, sulfur dioxide is released into the atmosphere. Sulfur dioxide contributes to acid rain and to respiratory illnesses. Coal also emits mercury and other heavy metals into the atmosphere.
When you're pregnant, you learn that mercury is a neurotoxin, which doctors advise staying away from because of the effects it can have on unborn babies. And that mercury and other toxic metals, like lead, can also wind up in water and soil, especially near coal mines.
The use of coal and oil and gas creates pollution at almost every step, well before the fuels are actually burned. Fossil fuel extraction, refining, and manufacturing of byproducts all have emissions that are unhealthy for communities and for workers.
And I mean, it's not hard to believe that breathing thick clouds of coal dust can't be good for you. But come on, don't we have regulations to protect us from that? Well, yeah, we do. Thanks to policies like the 1970 Clean Air Act, gas-burning cars have catalytic converters to filter out air pollutants. And coal and gas power plants have devices called scrubbers that do the same thing.
The Clean Air Act of 1970 has been a real success story. It's been estimated to avoid 230,000 deaths every year. Well, unfortunately, there's no safe level of air pollution. Almost every human on Earth, even in wealthy countries, breathes air pollution at levels that are unhealthy.
Wait, that can't be right, can it? I mean, I care a lot about clean air. My weather app has one of those little air quality trackers from the EPA. And most days it says that my air quality is green. It's good. On the rare days it's yellow. I might skip my morning walk. Well, actually, what I learned is that this tracker is focused on levels of air pollution that might make us sick within hours or days. It does not show us the low levels that might accumulate and contribute to illness over years. In the US, on the whole, we have impressively clean air. But even in the US, we're all exposed to a certain amount of air pollution, even on those good green days. For some of us, that pollution can add up, and that especially includes children, the elderly, those with pre-existing illnesses, and people who happen to live or work in more polluted places.
In the US, poorer neighborhoods often have a higher density of traffic, more highways that crisscross one another. Poor neighborhoods are more likely to have a dense concentration of manufacturing. So there's differences based on the neighborhoods people live in.
Even if you live in a neighborhood with clean air, our morning commutes can expose us to much higher levels of pollution.
A major health concern is diesel buses because kids are exposed to air pollution on their commutes to school. As a pulmonologist, I worry a lot about the respiratory health effects of air pollution in kids.
Let's zoom out for a minute. We know that being around fossil fuel pollution can make you sick, but how many people are really suffering from this? Now, answering that is tricky. No one's death certificate lists air pollution as the reason that they died, but public health experts can study what happens when our exposure rises and falls. Public health experts can also compare people who are a lot alike, but who breathe in different amounts of pollution.
The best numbers that I've seen from the recent State of Global Air Report by the Health Effects Institute estimated that over 8 million people died from air pollution in 2021. An estimated 2.3 million people died of air pollution exposure in China, 2 million in India. In the United States, an estimated 63,600 people died, and that makes air pollution the second leading risk factor for death after high blood pressure.
To put that in perspective, the total death toll of the COVID pandemic was about 7 million. Air pollution takes more lives than that every year. And most of that air pollution comes from burning fossil fuels. Look, every technology has risks. And maybe having cheap, easy access to energy is worth some exposure to air pollution. But as someone whose job it is to help build perspective on climate change and climate solutions, I do find myself thinking about this a lot. In fact, I think about it every time I meet someone who tells me that they're worried about the lithium in batteries or the silver in solar panels. I think that there's a tendency to assume that whatever we're doing now must be okay, and that therefore the risks of doing something new must be very worrisome. But what if the greatest costs are the ones that we're already bearing?
We have so much to gain from a public health standpoint, from switching from our dependence on fossil fuels to renewable energy. And importantly, those health benefits are immediate. I'm not talking about the changing climate here. I'm talking about the immediate benefits of cleaner air for our kids, for ourselves.
That doesn't erase my concerns about the materials that go into solar panels and batteries. It just reminds me that we're not adding these technologies to a world that, until now, was pollution-free. I mean, today, the world mines about 9 billion tons of coal a year, or more than 1 ton for every person on Earth. Oil, too, is pumped out of the ground in incredible amounts, more than 35 billion barrels a year. That's enough to overflow 2 bathtubs for every person on the planet. And that energy system, as we learned today, comes with loads of pollution. And I have a lot of hope that our future energy mix will come with a lot less. That's our episode for today, but if you have your own questions about fossil fuels and clean energy technologies to replace them, well, we love hearing from our listeners. Leave us a voicemail at 617-253-3566 or visit tilclimate.mit.edu/ask. Today I Learned Climate is the climate change podcast of the Massachusetts Institute of Technology. Aaron Krol is our writer and executive producer. David Lishansky is our sound editor and producer. Madison Goldberg is our associate producer. Michelle Harris is our fact checker. The music is by Blue Dot Sessions, and I am your host and senior editor, Laur Hesse Fisher. Thank you to Dr. Mary Rice for speaking with us, and to you, our listeners.